Hello everyone, in this video we are going to see the concept of recursion using the stacks. We know that stack is the last in first out data structure, and the repetitive calling of the function itself is called as an recursion. So the nature of the stack as well as the function call resembles. So stack is one of the best application for finding the recursion of the number. Let us here see two applications here. One is the recursion with the Fibonacci number and the recursion used for the factorial number. Let us see first of all what is recursion. A recursive function can go infinite like a loop. To avoid infinite running of the recursive function, there are two properties that a recursive function must have. So here we have a basic criteria, and then we have the progressive approach. So the basic criteria defines the condition on which the function has to be stopped, and the progressive approach recursively call the same procedure where each time a progress is made and the progress comes closer to the base criteria. So that is the concept of recursive function. Let us see the two examples of Fibonacci series and the factorial function. So let us see first of all how the factorial is calculated. Factorial of any number is calculated by repeatedly multiplying the successive numbers. So this forms one recursion concept. Suppose for example you are going to find 4 factorial. We first find 4 into 3. You get the product, and then with that 12 we multiply the next number into 2, that is 24. Then with that number again recursively you multiply by the next number, we will get to 24. So we are successively multiplying the numbers in a recursive fashion. So this factorial, finding the factorial of a number is an example of recursive function. Okay, now let us see the program now, how the recursive function is done here. So the factorial, fact comma n is the function, and fact and n are the parameters. If n is equal to 0, then set fact is equal to 1, because 0 factorial is equal to 1. Return the function. If not, we have to find the successive values. How to find? By calling the number. You can see here factorial is the name of the function. Here call factorial. Now the factorial function is called within the factorial function itself. This is called as recursion. A function calling itself successively is called as a recursive function. So this factorial is the name of the function. This is the call of the function. So the function call is made within the same function with the parameter n minus 1. Initially n, and then when it is called it will multiply by n into n minus 1, and then the answer will be stored into the variable fact. Initially fact is equal to 1, and then successively when there are more numbers we have to multiply the consecutive numbers and store the answer. So fact is equal to n into fact, then return. So this call factorial recursively calls the factorial function to for successive multiplication. So this is how the output comes for a factorial of the number. Let us see the next example, which is the Fibonacci series. We know that Fibonacci series is the series generated by adding the two consecutive numbers. So this also is an example of recursive, where recursively two consecutive numbers are added. So how it is done? By this procedure, Fibonacci fib of n. Fib is the Fibonacci series number, n is the number of terms. How many terms you are going to generate? If n is equal to 0 or n is equal to 1, then set to fib is equal to n. That means whether number of element is 0 means there is no factorial, so fib is equal to also 0. If n is equal to 1 means fib is also 1. Otherwise we have to create the series. How to generate the series? By calling the function. Call Fibonacci fib a comma n minus 2. Here Fibonacci is the calling of the function within itself. So this is the function Fibonacci, and this is the function call for Fibonacci. The function Fibonacci is called within the function Fibonacci itself. This is called as an recursion with the parameters fib a comma n minus 2. Next call is made by call Fibonacci fib b comma n minus 1. That means when the successive calls are made, n minus 1 and n minus 2 are added to get the fib value. Then the values are exchanged. Set fib is equal to fib a plus fib b. That means the consecutive numbers are added to get the number in the series. So that's all you have to return the function. So this is also an example of recursive procedure to find the Fibonacci series. So this also resembles the last in first out operation of the stack. So these two examples are the familiar examples they used to represent the stack operation. So this is a simple concept, and now the output of this Fibonacci is like this. So you have to say number of elements is 15. So 0 and 1 are the initial values. How the next element is found out? 0 plus 1 is 1. This is done. Now again Fibonacci, a call is made. Now 1 is in the result. Now 1 is the successive number. This is Fib A and this is Fib B. Add this, get the number 2. 1 plus 1 is 2. Set aside the value. Now this 1 and this 2, 3. Get the answer. Then previous 2 and this 3, 5. Previous 3 and this 5, 8. So this is how the successively, recursively the values are added to generate the Fibonacci series. So hope this simple example will tell you how the recursion is used in finding the Fibonacci and the factorial, and thanks for watching.